Hi there, everyone. This is Bob Martin, the RCSubGuy with the Nautilus Dry Docks, and last night I had the opportunity to get onto a video chat with Lucas out of Brazil. He is a very motivated scratch builder out of Brazil who just became fascinated with RC submarines and built his very first one over the course of 3 months. He reached out, we had some conversations about ballast systems, and we finally decided, for the sake of his listeners, and maybe for mine as well, it'd be a great idea to record our conversation. So I really hope you enjoy the following, and we'll catch you next time.
Guys, this is Bob, and he's specialist in building submarines RC. So Bob, how did you first get into RC submarines?
I'd always thought that they were fascinating, and ever since I was a little kid, I would doodle, little drawings of them and how I would build them. But it wasn't until about 1998 that my journey in RC submarines began. And the way that happened is I found a website from a lady in the United Kingdom by the name of Vicky Ford. And she was building from scratch a remote controlled Disney Nautilus submarine that you see on the board behind me. And so she had posted up all of her blueprints and all of the photos of her progress. And so I decided to follow in her footsteps. And what ended up happening ultimately is she made it to the point where she was molding her hull, because she'd made it out of wood, and she was molding it in fiberglass, and her master pattern fused to the mold and destroyed it. And so she never actually ended up building an RC submarine. And so it was up to me to teach myself everything that I needed to know to finish my project. And ultimately it took 3 years to build my first submarine.
Wow, 3 years. And was there a specific moment or model that sparked your passion? Why is this one this one, right?
So it was primarily, and I'm ashamed to admit it was primarily because it was the one she was building. If she would have been building a different one, it probably would have been a different submarine. But over the course of the last 26 years, I've become intensely passionate about that submarine as I learned more and more about the history of it and its importance to Walt Disney and to the entire entertainment world, and just the passion that people have for that particular submarine.
Bob, for those who never seen one, what is exactly an RC submarine and how does it differ from surface RC boats?
So good question. A submarine, an RC submarine, is more, like an RC helicopter, in that you're operating in 3 dimensions under the water. So you've got pitch, roll, and yaw that you need to contend with. The thing that's different, though, between operating an aircraft or a helicopter is we're literally operating in the most inhospitable environment on the face of the planet. Water is far more complex to navigate through than even outer space. And so you need to contend with not only making things functional, but keeping water out of all of the important bits of the submarine, and then contending with how the submarine performs, not only statically hovering, but moving through the water and the different ways that the water interacts with it. So they're very, very complex. And I mentioned this in my book. RC submarines is really a hobby for, I hesitate to use the word, but the elite. It takes a certain mentality of individual to succeed in the hobby. They need to have, or at least be willing to learn fabrication and electronics and radios and hydrodynamics and, all of these different things that need to work together to make a submarine actually function. So they're very complex, but very, very rewarding as well.
So Bob, this question I'm gonna ask you: how do you control a model that you can't see under the water? For example, in my submarine, I use the PS5 controller. It was not really good, but it worked. And I want to hear from you: what's the best way to control a submarine under the water, and if there is a cheapy way to control it, because remote controls are expensive. So it's two questions: how do we control, and if it's possible, like for hobby in a pool, I can use something that is cheap.
So, yes. The answer is yes, but there's a but to that. So when it comes to controlling a radio-controlled submarine, the lower the frequency you transmit on, the better the waves propagate through the water. So in Europe, and I believe where you're at, 40 megahertz was at least the standard frequency for surface craft. Here in North America, it was 75 megahertz. Both of those frequencies penetrate the water quite well. Unfortunately, when you get into like hobby grade radios, you're talking about hundreds of dollars typically to get into it. Now, if you look now, a lot of people are getting rid of those low frequency radios in favor of the high frequency radios, the 2.4 gigahertz, the 5.8 gigahertz. So sometimes you can get them off of like eBay or swap meets for $20, or something like that. That would be ideal. To get a hobby grade transmitter, because they were purpose built for what we're trying to accomplish, broadcasting on the correct frequency. Toys that you get, like from China and stuff like that, the little remote controlled submarines. I've seen people use those controllers, but you have very, very, very limited range because they're broadcasting usually at 433 megahertz at low power. They're designed, just for people to be standing next to and have fun in an aquarium or a pool or that kind of thing. The other option that I've experimented with and done successfully is actually using 2.4 gigahertz. And if you buy, for example, radios for RC cars, because there's so many of them, they tend to be a lot cheaper. You can get them for, and I'm talking US dollars here, 40, 50, 80 US dollars. So, not overly expensive, but brand new and with the most modern functionality to it. Now, those are all going to be broadcasting on 2.4 gigahertz. So you need to make a modification to the receiver to add an extension to the antenna to keep the antenna above the water. And so if you put that up through the mast or the periscope of your submarine, you can still dive. You just got to make sure you keep that periscope up above the surface of the water. And it adds a level of complexity, but you have a fully diving submarine that'll go completely under the water, and then you track its progress as you're moving by the periscope that's sticking out of the top of the water.
I'm planning to make just like a box with buttons. I do not want to use a bot controller, but I think a lot of people don't want to have this work to make the controller. But I think I will do in mine. I will create a box with buttons, and I'll create something for that.
But it'll still operate on radio waves or with a wire?
No, radio waves, but I will do a box with buttons, lights
Sure.
and everything. I think it's gonna be more cool than a controller.
Yeah, for sure. There's no reason that you couldn't do that. Now, obviously, a lot of times you lose the proportional control. So, to move the rudder just a little bit and that kind of thing. Usually with buttons, it's 100% middle, 100%.
I got
So
you can with something in hands, you can aim to it. Yeah.
What I was getting at is, with a button, it's on or off. You know, with the switch, it's on, middle, or reverse. So there's nothing in between. So if you're just trying to make small control changes, you can't really do it because the model will want to go full dive or full rise, and nothing in between, nothing subtle or you know. So it becomes more challenging to operate. Absolutely, it'll work and it'll be exponentially cheaper, but it'll just make the operation a little bit trickier.
So Bob, let's talk about what materials and components are used in construction of submarines.
So traditionally, the hulls were made out of fiberglass, and it's readily available. It's cheap. You know, it's used on cars and boats and all sorts of things. You can usually get a jug for $10 or something like that. And you can do many things with it. You could build a hull, for example, out of water-friendly materials. You could make it out of plastic, you know, or that kind of thing. Or you can make it out of wood and coat it with resin, fiberglass resin, in an attempt to seal it. Now, that historically doesn't work well. It won't last a long time, but it's cheap and easy to do. If you're just trying to get into the hobby to see if you enjoy it, that might be lots of fun. You build it out of wood, coat it with the resin, and make it waterproof.
I would recommend, if you're watching this for the first time, fiberglass. I had my first time working with fiberglass, and I really like it because you can create your size. You can make it the way you want. You can just model it, and it's easy to work. It's just, you know, smelly, but
Yeah.
if you're using protection, you can use fiberglass, and it's just okay.
So there's two main types of resin, fiberglass resin. There's polyester, which is what you're talking about. That's the smelly, stinky, cheap stuff. If you pay more, and sometimes it's about double, but it's still pretty, because they use on boats all the time. Epoxy fiber resin, that doesn't stink. And there's an interesting, fun way to build your submarine. You make it out of foam. So, you know, like the construction foam that you get from like a hardware store, or the packing foam that you get in boxes, you can carve and sand the shape of your submarine. And then if you put epoxy fiberglass and cloth over the top, it'll harden. And then you just cut it open and pull all the styrofoam out. And now you have a fiberglass hull that's hollow inside without having to worry about anything. And now the last thing that I wanted to mention, because this is becoming more and more pervasive, is 3D printing. So more and more people are purchasing 3D printers, and there's tons of files out there that you can download that you literally just hit print and it spits out a submarine.
So Bob, now I want to ask you something. I remember you were talking to me before, and you said that you already constructed a submarine for NASA, and I was really curious to hear a little bit about this story.
Sure. So this was I was approached by NASA to help them create a prototype of what they called the Titan turtle. And this was envisioned to be a probe that they were going to send to Titan, which is one of the moons of Saturn. And the oceans on Titan are made from liquid methane. And so the challenge that they had was they needed to create a submarine that would operate without fast moving parts like a propeller. Because if you move something quickly through liquid methane, it turns into a gas. And so they envisioned a turtle with big flippers that would move slowly up and down and propel it through the water. Ultimately, I created a scale model of it about this big. And the prototype that we had built for them used propellers because they wanted it for this production, because the Discovery Channel was coming out to film it. Wow. At their facility. And so I got to go out to the NASA facility, put it in a swimming pool, and drive it around while Discovery Channel filmed it. Ultimately, they wanted me to build like a 5-foot diameter version with like steel components that would stretch. And at the time, I didn't have the capabilities of doing that, but I did have the chance to work with NASA to build a really cool prototype of the Titan turtle.
Pretty good. So, what kind of propulsion and control system do you prefer?
So the simplest one that I would recommend, you know, for beginners, I'm assuming most of your viewers are going to be, is just a simple single propeller on the center line of a boat. It spins in one direction to go forward and spins in the other direction to go in reverse. You don't need to worry about fancy propellers or anything like that. The really neat ones that you see on real submarines, the curved scimitar blades and that kind of thing, you don't need to use those. They're designed more to be quiet on the full-sized submarines than efficient. So if you just find a standard, you know, 3-bladed propeller from a toy boat, you can absolutely use that.
Do you use software or tools, or do you have a trick or something to test before putting your submarine in the water? Do you do tests
Yes,
before putting in the water?
Correct. Yeah, absolutely.
What kind of tests?
So when you're building a submarine, it's made up of a series of parts. And so each part is tested before it's installed to make sure it's working. I'm literally just putting a cylinder together today, brand new, and the pump didn't work. And so I found it before I put it together. And so test everything before it goes in. The biggest challenge with an RC submarine is the waterproof container, the watertight container that you're putting all of your electronics and the battery and all of that stuff in. Making that completely waterproof and maintaining accessibility, because you could literally slather it with silicone and call it waterproof and be done with it. But you need to be able to get into it and out of it and put it back together and all of that. So what I would typically do is I'll build that waterproof box and I put a hose, a rubber hose attached to it. And I can put the compartment under the water and blow into the hose and look for bubbles. And that'll tell you before you put it in your submarine whether or not it's going to leak. And so that is the most vital thing that you can do when you're building your boat, is just build that module with all of your electronics, make it removable, because it'll vastly simplify things later on, as opposed to gluing it into your submarine where you can't get at it anymore. So make a box or a cylinder.
I had this experience. I was just trying to make a waterproof box, and every time I was putting it under the water, and my father came and said, "Hey, why don't you just blow it?" I said, "Yeah." And then I just started recording and blowing and said, "It works. We blow. If air goes out, do not put it in the water."
Yeah. So there's a couple of different ways that you can do this. So the fancy RC submarines have clear acrylic tubes with machined end caps, and they look very high tech and fancy. But if you go to the hardware store, they have like IP67 rated electrical junction boxes for building houses. Usually you'll see them on the outside where you have like a electrical connection. You can use those as a waterproof box for your electronic, and they're cheap. Here in the United States, they're like $5, and they come completely engineered and ready to go.
I have one question, but with IP67, we can just put in the water, or we have to do something more, like more glue or put something?
So the IP67 is rated to 1 meter for 30 minutes. If you're operating your submarine below 1 meter in a lake or a pond, you're doing it wrong. Because if you don't know exactly what's under the water, you're just asking to hit a stick or a weed or some fishing line or an old shopping cart. You don't know what's under there unless you're operating in a swimming pool or a crystal clear spring-fed pool, which is very few and far between. But usually as somebody who's been doing this for almost 30 years now, you're going to operate just below the surface. You're going to be driving along, you'll dive, you'll keep just below the surface. So a meter is a lot of room. The other thing that I've noticed is when they rate things to IP67, they'll go deeper. I've brought those things down to 8 feet of water, you know, to 2.5 meters, and it's been perfectly fine.
Bob, you did this with your hand, and I just remember a very important question I can't forget. We use ballast tanks to go down and to go up. So, what are your favorite and the cheapest ones? Your favorite? I want to know your opinion. Why? And which one is cheaper to build?
So, first of all, I'm going to clarify. A ballast system doesn't control your depth. A ballast system controls your buoyancy. So all a ballast system is responsible for is bringing a submarine from below the surface of the water to above the surface of the water. The ballast tank size only pertains to the amount of material that is above the surface water line of your boat. You can build a submarine, by the way, that is exceptionally fun, that has no ballast tank. It's called a dynamic diving submarine, and it would just have a little bit of, you know, the top of the sail sticking out, and you would use forward momentum and the dive planes to pull it under the water. I've built many submarines like that, and they are very fun and very simple because you're eliminating the need for a ballast system. So I just wanted to clarify that the ballast system just brings the boat from under the water to above. The thing that controls your depth are your dive planes. That's what pulls the boat down and pushes it up and all of that stuff. Back to your question about ballast systems, the cheapest and easiest to implement is a pump system, a reversible pump system. So this would be able to bring the boat from just the tippy top of the sail sticking out of the water to full surfaced water line. And so you would use this pump, and the best source for them are old windshield washer pumps from cars. Those are called gear pumps, and they can pump water both forward and reverse. So that's a very important difference between like diaphragm pumps, which can only move in one direction, or centrifugal pumps, which only go in one direction. So go to your old auto wrecker and get an old windshield washer pump, and that'll pump forward and backwards. And so basically the way it works is you have a ballast tank with a little hose in the bottom attached to the pump, and then an air line going up to the top of your periscope. Put the pump one way to go down, put the pump the other way to go up, and that's it. All you need is a pump controller and the pump.
So Bob, I never studied ballast tanks. When I started my submarine, I had this question. I need to go down, and what the real submarine they use? They use CO2. And I said, hey,
compressed air, actually.
Air.
Yeah.
I said, wow, I want to use compressed air. So I bought CO2. I asked you how to use CO2. And then I was testing in my house. Sometime I sucked CO2 and I almost died. And I think this is not for beginners. CO2 is not for beginners.
It can, and I want to make a comment here. CO2 can be dangerous. Those little canisters are storing CO2, liquid CO2 at like 800 psi. So if something happens and they rupture, they can explode. And you know, if an airline or something like that ruptures at that high pressure, it can cause damage. It can hurt people. You can use it, but it requires a higher level of engineering and quality parts. You do not want to we use the term half-ass. You don't want to jury rig something. It needs to be all professional parts with good regulators to bring that pressure from 800 to like 15 psi.
So I did some crazy stuff, you know. I used it just.
I bet you did. We all did.
But talk is really good. I have just a few questions so we can finish. Uh, can you share a time when something went completely wrong? Maybe a submarine sank that you have to swim for it.
Mm-hmm.
You're a professional, but I think you had those times that you have to swim
Yep.
for it.
So they say with RC submarines, it's a matter of when, not if, your submarine will sink. It just happened, and I had a video documentary about this. It was a U.S. Virginia class submarine that I had built for a customer, and I was bringing it out for its maiden voyage for testing, and all it needed to do was perform, and then I was going to hand it off to the customer, and I was going to move on to the next project. But what ended up happening, the submarine, we found out afterwards, began its dive and dove down and snagged weeds. And it got pulled down underneath the water. And because it was wrapped in weeds, the ballast and the positive buoyancy couldn't bring it back up. And so it was lost. Basically, it went under the water, and we had no idea where it was or what to do. We managed to get a diver out within a few hours, but he could not find it. Ultimately, it stayed in the pond for 2 months before finally we managed to get another diving team in there, and they located it. And again, I've got this all documented on my website, but pulling it out, it looked like a muck colored monster. And so I did manage to refurbish it to get it back into operational condition. And actually the customer just came last week to pick it up.
Do you have questions about the submarine I was building and sending you pictures? Do you want to ask something for me before we end this interview?
Well, I'm mostly interested because one of the most expensive parts on a submarine is the radio, is the control system. And so I think what would be, and we don't need to get into the intricate details now, but what would be most interesting, I think, for your watchers is what you can do to create a low cost controller for the submarine. Because ultimately, I'd be willing to bet the components of the actual submarine probably only amount to less than $100. Depending on what you're doing.
Oh.
But the radios that I sell are almost $300 on their own.
Oh, I want to do that with just less than $50. I want to use components and things like this. Let me show you. Things like this, microcontrollers. I do a lot of work with these guys here, and they help us with a lot of things, like process payments, vending machines, and I'm bringing them now to submarines, and I really hope they worked. And I'm gonna use low frequency. I do not wanna use higher frequencies as I was using before reading your book and talking to you. So I'm trying to create our own controller, and then people can make it better. They can make it more professional. But
Sure.
I wanna create it. I wanna choose the antennas. So I'm gonna buy some antennas and say, hey, this is good. This is not good, and do a lot of tests. So as I said to you, I do not want something in my hands. This is it's my submarine. I want to put something that is mine. I want, like a box tool, like in the army. I don't know if they use that, but like a central that I can control my submarine, so I can operate it remotely, and I'll put antennas around in the pool, and then I'll have a lot of buttons, a lot of stickers, and I'll do something fun with it too.
Yeah. That's great. I would really recommend, there's a lot of components that people can get out of an auto wrecker yard, old cars. The motors that are used in the blowers, like for your vents, those are beautiful motors. The thing about the automotive industry, they don't want noisy motors, and by noisy I mean electrically noisy, because most, especially old brushed motors, when they operate, they create radio frequency interference. But in cars, they have inbuilt suppression because they don't want your radio to get staticky.
My first experience, I used one motor that one that cleans the glass, and washing machine, this part of the washing machine, and I connected them. But then the water just, we didn't have lubrication here, so we need to use something that is lubricated. So that is also a challenge. This part lubricated.
Are you talking about seals, like to seal the water, or just like a bushing to stop it from?
A bushing, but with lubrication. I didn't use it. I just used it in washing machines, and then with time, it just, it didn't.
Got tight. Yeah.
Got tight.
Yeah.
So we have a lot of challenges to face. So that's why I am here talking to you, and I wanna be more time doing submarines. And people are calling me, hey Lucas, come here, talk about your project, show us what you used. I used PVC pipes, very low cost pipes, and I could seal it. I printed 12 times a round piece to connect it. I had to print it 12 times to make a perfect seal, and then I got it, and then I just painted with, I don't know how to say in English, but that thing that you put in the nail.
Fingernail polish?
Yeah, nail polish, and then it's completely sealed, 100% sealed. And said, wow, now I'm ready to put my electronics under the water with safety. So I built airplanes, cars, but submarines, and I'm sure people are gonna watch our video and then they'll say, I will start mine. And that's why I do it, and that's why you do it. We want to make people to build it.
I think what would be interesting, and I'm wondering how and when I could fit this in to my build queue, but it would be an interesting challenge to take your $50 and see what we could come up with. And I can reach out to my community here in the United States, and maybe we can have like a contest. $50 budget, build the best RC submarine that you can. And I would eliminate the radio from that equation, because people aren't going to build their own radio systems. But I think they could build the entire submarine if your budget was $50 US. I wonder what kind of submarines we would end up having. That could be something really, really fun to come up with. And if we could document it, then other people in your country, for example, could follow along how it's built from start to finish.
Yeah, that would be a good challenge.
Yeah. All right. I'm gonna have to think about that. We'll have to flex our creative muscles to keep under the budget.
Think about that, and we can do something together. Bob, thank you very much for your attention. I wish all the best success, and your channel is amazing. I'm gonna leave it here in the description. And thank you very much for all the attention that you gave to me. My questions, you always answered me in your channel, in your email. And to finish, I just have this to you. Thank you very much.
I love talking to people like you who are passionate about this, and who, despite lack of resources, become creative and just keep going at it. Like I said, my first submarine took 3 years, and I think you said yours was like 7 months or something. So you're doing much better than me.
I said 3 months.
Oh, 3. There you go. Much better than me.
Bobby, thank you. Thank you very much.